one's called Is It a Number? Given a string S, write a method that will return true if it's a valid single integer or floating number. Otherwise, return false. Some valid examples are the string 3, even the string 3 with white space on each side, and then negative 3.23. So they don't have to be whole integers. And then some examples that should return false. 3-4 or 3 minus 4, however you want to look at that. That's two separate numbers. Again, you have two separate numbers separated by white space, still invalid, even if it's only one white space. And then finally, if you write out the text name of the number, that's not considered a digit either, or a number. They unfortunately named their method isDigit, but we'll see that there are plenty of numbers with more than one digit that pass and are supposed to pass. So make sure when you write your own methods, you're not naming them poorly like this. This would have been much better called isNumber or something like that. So we'll get on with it. I'll show two solutions, quick ones. Feel free to pause first though and try your own, and then come on back when you're ready. The first one I'll do, we're going to use that parse and try parse methods we've seen with the integer class, but you may not have been aware that the double class has one as well. In the double try parse, and it's also got a parse, a regular parse. You'll note that, or you should recall, that try parse returns a double, whether it's, or I'm sorry, a Boolean, whether it's successful or not. And so if we try to extract a number from this string and it's successful, we'll get true. So we can simply return the result of this, and it will give us false otherwise if the input is not a number, or a valid double in this case. So we can do double val, set up our out parameter. We can do it another way where we just kind of do this all in line, but we'll say that double class try parse, we have our input, it's called S, and then we got to give it that out parameter, in this case val. We know that the result of this is a Boolean, so we'll return it. If it can extract a double value out of that, then good. And we'll go ahead and run this. I'll hit the test first. And if you want to be the old one-liner, you should be able to do something like this. Just kind of declare it right in place there. We'll hit it again, the larger collection, and it looks good. That's a lot of green. The submit button's active. So that was a pretty nice, easy built-in way for us to solve this problem. We didn't have to iterate over the string, look at it like a collection of chars, and then examine each character if it's a negative sign, if it's a valid digit, a number, you know, that would have been a lot more work, but you could do it that way. And that could be good practice if you're shaky with for loops and things like that. So nothing wrong if you did it that way. As I mentioned, but actually before we move on to the second solution, I had to use double here because some of the input comes in as double. We saw in the instructions there was an example of 3.23. We see in this test you got negative 234.4. And just note that double covers integers, right? You can think of the integer value 3 as 3.0 when it's converted into a double, so that's fine. Clearly it doesn't work the other way around. Integers don't cover doubles. They sort of truncate any fractional value if you try and put a double into an integer or convert it. So yeah, that's why I opted for double here. and not the int32 version or int version. So there's one. We'll move on to regular expressions. If you remember, the library for that is system.text.regular expressions. Okay, so this would be a good chance to practice those skills. You recall we have the regex class with a match method. We provided our input, and then the key is coming up with the right pattern, right? That's always the tricky part. You remember that match returns some kind of match object, which has a success property if it successfully matched the pattern in the input string. So we can return that. So what do we do here to get numbers? Well, I'm going to use those anchor symbols we learned about to sort of encompass the whole span of the input. Remember, the caret says match from the front. It won't allow any kind of preceding characters, and then match at the end is the dollar symbol, and it won't allow characters after the match, right? We wouldn't want 3.23 ABC, right? So that's sort of what I'm trying to accomplish there. And then note that our input may be negative, so let's account for that. We'll match the negative sign, and then we need a mechanism for saying this is basically optional. If you remember this handy sheet here, hopefully maybe you should bookmark it. It gives us a lot of these codes that we can use, and so let's find one. Optional, we want something that's here we go, quantifiers. Matches the previous element 0 or 1 time. That's perfect for us. The question mark. Right? You can have 0 or 1. You wouldn't want two negative signs. That would be not a number. So that says 0 or 1. Okay, good. Now we need to go into numeric values, right? We don't want letters in here. We want to hit numbers. So what can we do to catch that? Look at the \d, matches any decimal digit. That looks good. That's what we want. So let's go \d, and then I want at least one of these, right? Got to have some number there. So let's find one or more. That should be back in the quantifier section. One or more. Matches the previous element one or more times for the plus sign. So I'll go with that. Good. So now we have at least one digit. Now we want to hit that decimal point, right? And so you might just type in the decimal point like we did the hyphen here, but you should note that the decimal point, the period, is a special character in here, and so we're going to have to escape that so it doesn't do a wildcard matching. I'm going to try and find that for you. There we go. The period wildcard matches any single character except new line. We don't want that. To match a literal period character, what we want, you must precede it with an escape character. So use \period. Let's do that. Instead of just the period, I'm going \period, saying, hey, match a period. Don't substitute. Don't interpret that dot as some kind of wildcard thing. I'm actually looking for a period literally. Okay? And so if it is a decimal, it could have some more digits after it, right? So we should account for that. Again, we know that, oh, I'm sorry, I got a little bit ahead of myself, right? With the decimal point, we want to make sure it only happens 0 or 1 time. It's optional, right? Just like we did with the negative sign. So let's add that question mark to cover that. Then we can get on to possible digits that accompany a decimal point. So again, just like we did before, digits are specified with the \d. And note that we might have some cases where there are no fractional values. So I'm going to make these digits after the decimal point optional. Before we said, hey, we have to have at least one, so we use the plus sign. Let's find something that will work for allowing 0 or more. Should be back in the quantifiers. And notice the asterisk matches the previous element 0 or more times. So I think that should work. I'll go ahead and specify that. And then I think we've completed it. We don't want anything after that. No extra letters or anything. We've specified the whole pattern there, the whole input range from beginning to end. We're not allowing anything extra. Let's go ahead and run this. You know, there's one other problem here that I should probably address. If string is null or empty s, let's just go ahead and return false, right? If there's no input or the string is empty, it can't possibly have number characters in it, right? So it's clearly not a number. I'm just going to return false in that case, and that should cover us in the case where s is null or empty. Now I'll go ahead and attempt again this new pattern. Error on, oh sure, okay. So I'm going to use something, I don't know if we've used this before. If I put in the @ symbol here, it will sort of make this a string literal. And then it won't try to use these backslashes as escape sequences. If you remember, we did something, I believe, with tabs. We made tabs by hitting \T. And there are a bunch of other escape sequences that go with strings. And so I make sure it doesn't try to do any of that escaping when I put the @ symbol here. Go ahead and look that up if you'd like. Yeah, something about C# string and then put the @ symbol. So I think that'll correct this error. Let's try again. There we go, we got all the green. Looks good. They're going to allow us to submit. So I'll go ahead and fire this off real quick again. Remember the anchors from the front and the back. We enclosed the whole input range there. And we use the question mark to say, hey, the negative sign is optional. And we said, look for digits and make sure you have at least one or more. Could be 10, could be 1, could be 7, could be 300. Then we had to put \period so it didn't recognize the period as a wildcard. So we say a literal period, and then you could, again, like the negative sign, you could have 0 or 1, and then possibly some digits again after the decimal point if it's a fractional value, if it's a floating number. So, and then the asterisk was used for that to allow 0 in the case that we don't have any decimal values. So that's it. I know these things get really ugly fast, and you just kind of look at something like this and it gives you a headache. What the heck does that mean? But hopefully by stepping through this in little chunks, you can kind of see that now, and these become less intimidating for you. I'll go ahead and send off the regular expression solution. Let's see what other people did. Yeah, we got, just like we did with the double class, double, try parse, just like we did the first time. They used a float here. That was apparently good enough. Float's just like double, except there's a smaller range, I believe. I think it uses less bits. And see, they did int try parse or double try parse, but we saw that double covered integers, so I don't know that this is very desirable. And here you go, we had someone who went through the for loop, examined each character in turn, allowed possibly for a negative symbol at the very beginning. Then they're checking for basically either that the character is a number or a decimal point. I have concerns here though, that what if you had multiple decimal points in the input string? Would this pass it? It shouldn't, you wouldn't want it to pass in that case. So I'm a little concerned about that solution, but I'm not going to test it. So yeah, feel free to check those out. Otherwise, you know what to do if you have questions. Otherwise, we'll keep rolling. Thanks for watching.